Some problems in algebra involve finding the maximum or minimum of something, the optimum use of something, and it's very applied to real life. Let's take a simple example. Suppose you had two dogs, and these dogs didn't get along. So you had a dog and another dog, and you were going to fence them in a pen with 1,000 feet of fencing. So you had 1,000 feet of fencing. And so you're going to create this rectangular pen around these dogs. However, you're going to divide it equally for each dog because you have to fence them off because they fight all the time. So you have to keep them separate. Okay. Let's find what dimensions give us the most optimum area, the highest area, the maximum area. What dimensions of fence, of dog pen? Well, you know we have 1,000 foot of fencing, and so let's denote the width of the pen as x. So we have 3 x's there. So what would the length of this pen, because remember we want the area of this rectangle, what would the length be? Well, we know we have 1,000 foot of fencing, and we have 3 x's for the width, so we have to subtract off those 3 x's, and we have to divide that, what's remaining, equally amongst either length there, either side. So we have to divide that by 2. Okay, so now we know the area of a rectangle is what? Length times width. And so the length in this case is 1,000 minus 3x over 2. And the width is x. So here we have an area function. And now we want to find what value of x gives us the maximum area. What width should we put to give us the maximum area? We can multiply this out if we wish. A equals 1,000x minus 3x squared over 2. And if you wanted to simplify it further, you'd have A equals 500x minus 3 over 2x squared. And you can actually find the maximum because this is a quadratic equation, and you can find the vertex of this quadratic equation. So we have the equation A equals 500x minus 3 halves x squared. And we want to find the vertex of this quadratic equation. So remember, the vertex, we first have to find negative b over 2 times a, and then f of negative b over 2a. So in order to do that, we have to figure out what b and what a are. Well, a, even though it's not written first, is negative 3 halves, and b is 500. So if we want to find the vertex, we take negative b, in other words negative 500, divided by 2 times negative 3 halves. And if we calculate that out, you see these 2's will cancel, and so we'll have 500 over 3 is my x coordinate of the vertex, and that's 166.7 approximately. And then we have to plug that in to find the actual area of the pens. But this value of x gives me the maximum area of those pens. We're going to see how to do this on the calculator. Okay, we want to graph this function. Let's click y equals. And the function we're graphing is 500 minus 3 halves x squared. 500x minus 3 halves, which is 1.5 x squared. We have to set a window for this function. I hit window. The minimum should be 0. The maximum I put at 500 for x right now because we have 100 foot of fencing. You're not going to have more than 500 for the width. And let me set my scale at 1 and click zoom 0. And now it's calculating, and it's going to graph that function in that window. Here we have the maximum. We want to find the maximum. We go second trace, scroll down to maximum, enter, scroll to the left of the maximum, hit enter, scroll to the right of the maximum, hit enter, enter again, and we see that the maximum, the width of 166.66 or 167 feet gives a maximum area of 41,667 square feet. So if we have three widths at 167, what's the length going to be? Well, the length will be 1,000 minus 3 times 167 approximately, and then you have to divide that in 2 because you have two lengths, and that leaves that each length is going to be about 250 feet. So you're going to have a pen that's 250 by 167 with a little fence also down the middle to divide off the two dogs.